Newton's laws of motion are three fundamental principles that form the cornerstone of classical physics. These laws, formulated by Sir Isaac Newton in the 17th century, describe the relationship between a physical object and the forces acting upon it, laying the groundwork for our understanding of mechanics and the behavior of matter. First law. This law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. In other words, objects tend to stay in their lane unless something causes them to change direction or speed. For instance, a soccer ball will sit idle unless a player kicks it, and a rolling ball won't stop until friction or another opposing force comes into play. This concept is known as inertia, the tendency of objects to resist changes in their state of motion. Second law. This law defines how the velocity of an object changes when a force is applied. Specifically, it states that the acceleration of an object depends on two factors: the magnitude of the force acting on the object and the mass of the object itself. Mathematically, it is expressed as F equals ma, where F is force, m is mass, and a is acceleration. The heavier an object is, the more force is required to accelerate it. This principle explains why pushing a loaded wheelbarrow requires more effort than an empty one. Third law. Newton's third law famously states that for every action, there is an equal and opposite reaction. This means that when an object exerts a force on another object, the second object exerts an equal force back in the opposite direction. For example, when you jump off a diving board, your legs push down on the board, and the board pushes you upwards with an equal force, propelling you into the air. Similarly, this principle underlies how rockets launch into space. The engines expel gases downward, which pushes the rocket upward. In summary, Newton's laws of motion elegantly describe how objects move and respond to forces. They demystify the mechanics behind everyday phenomena like driving, walking, and flying, while also providing the foundation for advanced engineering and scientific exploration. These laws remain as relevant today as they were centuries ago, revealing the predictable dance of forces and objects that shape our world.
Thanks for watching. If you found this video helpful, please give it a like and subscribe to our channel for more fascinating insights into physics and science. Stay curious, and we'll see you in the next one.